Chapter 15, Problem 12. What factors affect the rate constant for a reaction? So we know when you look at a rate law that the concentration definitely affects the rate. That's because more concentrated means more collisions per second. But the rate constant takes everything else into consideration besides the number of collisions per second. So one thing we need to address is activation energy, which is given the symbol E sub A. So the activation energy is the minimum energy required to get the reaction started. So just because molecules collide doesn't automatically mean they're going to react. They have to collide with that minimum energy in order to get the reaction started. How can we change that? Well, let's say we look at the number of molecules as a function of speed. So we actually have seen this graph in chapter 5, the gas chapter. So let's say you're at one particular temperature. So at that particular temperature, you should get a whole range of speeds. You don't get all gases moving one speed. You get kind of a bell-shaped curve. So let's say this is arbitrarily at 50 degrees Celsius. What would happen to the curve if I change it to 100 degrees Celsius? Well, you're still going to get that speed of 0. So you're going to get that left point. But the right point, you should increase. So that's going to pull the whole graph wider, which at the same time happens to shorten it. So let's say this is at 100 degrees Celsius. Okay, now not all of these speeds are going to work for any particular reaction. So let's arbitrarily pick this speed. So let's say that's the minimum speed that's going to work. So if I take that point and just extend it up, looking at the 50-degree bell curve, you only have this much. So out of that entire curve, you only have that many molecules that are going that minimum speed. But if we look at the bell curve for the 100 degrees Celsius, we see we have all of these. So you have a larger fraction that are going that minimum speed. So we could say, as temperature goes up, the fraction of collisions with sufficient energy, aka the activation energy, goes up. So we said the activation energy is that minimum energy required. Is it possible to change that? Well, it doesn't change if the temperature changes, but the activation energy can change by adding a catalyst or an inhibitor. So catalysts, they lower the activation energy, and inhibitors raise the activation energy. So imagine, if you will, that you're moving your minimum speed point. If it's a catalyst, you're moving it to the left. So you're not changing the temperature, so you're not changing the shape of these bell curves, but you are changing that shaded area under the curve. And so by lowering the activation energy, but not changing the temperature, this will also cause the fraction with sufficient energy to go up. Okay, so basically there's two things that are going to affect our rate constant: activation energy and temperature. As temperature goes up, the rate constant goes up. And as activation energy goes up, the rate constant will actually go down. This can be seen in what's called Arrhenius's equation. So he said that the rate constant is a constant called the Arrhenius exponential factor constant times e to the negative activation energy over RT. Now, just FYI, this constant has to do with how the molecules collide. So just because they're colliding with sufficient energy doesn't automatically mean a reaction is going to take place. They have to collide with the proper orientation. So A is like a statistical value that takes into consideration all the possible collision orientations and what fraction of them are the proper orientation.